Atmosphere and oceans are linked in a complex system. For example, atmospheric circulations propel ocean currents. Oceans put heat and moisture in the atmosphere. The trade winds over the tropical oceans propel ocean currents from east to west, for example, from the eastern Pacific to the western Pacific. El Niño refers to a disturbance in the ocean currents in the tropical Pacific, which is linked to a disturbance of the atmospheric circulation. The changes of the ocean and atmospheric currents in the tropical Pacific region is named ENSO, El Niño Southern Oscillation. It starts with the observation that every 3 to 8 years the surface waters of the eastern Pacific near Peru become unusually warm around Christmas. In a normal year, the trade winds move the warm surface waters near the equator westward. That results in the water levels in the western Pacific to be approximately half a meter higher than in the eastern Pacific. These winds promote the upwelling of cold waters west of South America. Warm waters cause low pressure and convectional precipitation over the western Pacific. In an El Niño year, the trade winds weaken or even reverse and flow eastward. Warm water accumulates near the west coast of America. Immediate effects are droughts over Australia and Indonesia, warm water at the South American west coast, and torrential rainfalls over Peru. This illustration shows again that on the left side, in a normal year, we see low pressure over Indonesia and northern Australia. During the El Niño year, the low pressure moves east to the central part of the western Pacific. Strong trade winds moving the surface water westward cause the upwelling of cold water near the South American coast in a normal year. This upwelling is prevented in an El Niño year as a result of the warm surface water moving eastward. This chart shows the sea surface temperature anomalies of November 1997. Red colors indicate temperatures above normal, blue colors below normal. The unusually warm waters off the coast of South America indicate an El Niño year. A La Niña year is marked by conditions that are opposite to the El Niño year. We basically have amplified normal conditions. So very strong subtropical highs, very strong trade winds, more upwelling of colder water at the west coast of South America. Torrential rainfalls in Australia and Indonesia, which are associated with a very strong low pressure system over there. Historically speaking, La Niña and El Niño events tend to develop during the period April to June, and they tend to reach their maximum strength during December to February. Typically they persist for 9 to 12 months, though occasionally they can persist for up to 2 years. Given that we can measure sea surface temperatures from satellites, all El Niño or La Niña events have been well documented in the last years. Notice the strong El Niño in 1997 or in 2002, or the La Niña of the year 1998 or 2000. This disturbance of the ocean atmospheric circulation in the Pacific has consequences worldwide through an effect that we call teleconnections. The disturbance affects pressure patterns, subtropical high pressure systems, Rossby waves, and so on, and therefore has effects worldwide. For example, an El Niño situation will often be associated with a persistent low pressure system over the North Pacific. South of this low pressure system, the jet stream steers wet weather into California and the southern United States, typically from October to March. A weak polar jet stream over eastern Canada causes warm temperatures over large regions in the northern United States from December to March. The opposite condition, La Niña, is often associated with a persistent high pressure system south of Alaska. It forces the polar jet stream into Alaska, Canada, and the western United States. The southern branch of the jet directs moist air into the Pacific Northwest region, causing wet winters. On the other hand, the southern United States are relatively warm and dry in winter. El Niño causes effects worldwide, in addition to the rainfall in Peru and the rainfall patterns in the United States that were already mentioned. El Niño events are also often associated with droughts in Brazil or in South Africa, or droughts in India, in Indonesia and Australia, or heavy rainfall over Central Pacific, just to name a few. The chart shows that El Niño and La Niña events have occurred through history. Particularly strong El Niño events were noted in the early 80s and 1997-98. Another atmospheric oceanic circulation pattern is named North Atlantic Oscillation, or NAO. It affects the weather in Europe and the east coast of North America. It is expressed as the pressure difference between the Icelandic Low, as an example of the subpolar low in the northern Atlantic, and the Azores High, as an example of a subtropical high pressure system. During the positive phase of the NAO, we find a large pressure gradient between the subtropical high and the subpolar low that strengthens the westerlies. Winter storms across the Atlantic are steered on a more northerly track. That causes warm, wet winters over northern Europe, mild and dry winters over central and southern Europe, wet and mild winters over the eastern United States, and cold and dry conditions over northern Canada and Greenland. On the other hand, the negative phase of the NAO causes a reduced pressure gradient, weaker westerlies, wet winters in the Mediterranean region, cold and dry winters in northern Europe, cold and snowy winters along the east coast of North America, and mild winters in Greenland. The North Atlantic Oscillation varies from year to year or even from month to month. However, it can have the tendency to remain in one phase for several years. Given its impact on severe winters in various parts of the world, it is interesting to see how the NAO links to major events in world history. Historians remember the Great Blizzard of 1888 in New York City. As a consequence of this event, telephone cables were put underground and the subway system was approved in 1894. It is interesting to observe that the previous decade was characterized by mainly negative or weakly positive NAO phase, which, you remember, often comes along with cold and snowy winters along the east coast of North America. The Titanic sank in 1912 after a collision with an iceberg around 400 miles off the coast of Newfoundland. It is noteworthy that this happened in a persistent positive NAO phase, which caused warmer sea surface temperatures in the northwestern Atlantic and possibly contributed to icebergs breaking apart more easily. In addition to many other political dimensions, Russia suffered severe winters in 1916-1917, which led to severe food shortages, and subsequent riots led to the February Revolution, which ultimately resulted in the Soviet regime to be established. The extremely cold winters are likely to be associated with a negative phase of the NAO at this time. In the winter of 1942, German troops were forced to halt their advance in Russia as a result of an extremely harsh winter. Following two other cold winters, a third harsh winter seemed unlikely at this time. However, German meteorologists were obviously not aware of the strong and persistent negative NAO phase. Another strong and persistent negative NAO phase in the early 1960s caused the coldest winter of the 20th century in Great Britain in 1963 during the British Big Freeze, a remarkable event for the British because the Thames River froze over.